Okay, so we're through with number 2. Now, let us now look at and move on to the third one. What are the different considerations in lessons, now preparing the lessons for a virtual lecture? So I think we have to move fast here because there are plenty of slides for this component. So number 1, we have to focus on most essential learning competencies. I know that since we are master of content, the teacher is actually and is always tempted to pour everything to their students because what we want is for them to master what we know. But during the time of pandemic, the synchronous session is really limited. That's the problem. And so we have to focus on the most essential learning competency. And for example, in the case of the Philippines, the Department of Education mentioned that there are so many considerations for them to choose or to tell you or to assign this competency as an essential competency or not. So it is flashed on the screen, of course. And then if you're going to look at those, if you're going to read through the characteristics of an essential learning competency, then you may somehow recognize that they should be enduring. So what does that mean? So what is endurance? No, a certain competency is enduring if it is considered to be the primary determining factor. Wherein that competency, no, even out of school, after the school, they will use, or that competency is important for them. So for example, learning competencies like research skills is very important. Reading comprehension, writing, map reading, these are hypothesis testing, especially in science. All of these are very important, and I think there's no single topic that can teach them. So the DepEd, in the case of the Philippines, of course, we have the MELTs to support this the development of these skills and competencies. Yan. Okay. So another thing that I would like to tell everyone is that we have to be aware of the critical and hard to learn contents, especially, for example, for us, because we are teaching, for example, me, I'm teaching chemistry. Of course, we recognize that there are some prerequisite knowledge that must be taught to students before we allow them to move to the next level of the harder or more difficult concepts. So it should be clear to us. For example, if you're a teacher, you know that studying interactions, between molecules, between atoms that comprise a molecule, those are important. But when we look at the applications, for example, mga environmental applications, we have to recognize that, for example, learning bonding is very important, and because if you know the difference between intra and intermolecular forces, you can somehow understand that there are different intermolecular forces of attraction, and these forces of attraction, just like hydrogen bonding, is related to these events and phenomena that you observe, and these phenomena and things that you observe macroscopically are related to the applications of chemistry in some other subjects that we have. So somehow, if for example, you are just teaching bonding and then some of your students fail to recognize the importance of this concept, then more or less, we do not expect that they will proceed or progress to the higher levels of understanding the course or the subject. Okay, so provide context in both instruction and assessment. So you might be familiar with this. Some of you might be familiar to this excerpt. So it is titled "The Montylation of Traxolene." So let me read to you. Listen very carefully. So it is very important that you learn about traxolene. Traxolene is a new form of zointer. It is montyled in seristana. The seristanians glycerate large amount of ebon, then bracter it to quasel traxolene. Traxolene may be one of our most localized nest in the future because of our zointer lessilage. Now, it is really hard to believe, but it's true that when we give some questions to students, regardless of a batch, we started this 2015, I think, asking some our sections, the different sections of students to read this, and then we give some questions like, what is traxolene? Where is it montyled? when you put a score on their answers, they will get a perfect score. They will get a perfect score. But when you ask them some further questions like, honestly, what did you learn about Traxolin? Do you even have a mental picture of what Traxolin is? Okay, so for those who are saying this is not even English, this is not English. This is not also Filipino. Okay, so this is actually a made-up language. But through context, just context clues, the students can actually give you the response that you expect. But the problem is when you ask them, so what is Traxolin really? Do you have a mental picture of what is that? Is it a fruit? Is it something that you can eat? Or is it a poisonous substance? They don't know. But they perfect the quiz about this excerpt. So what can we say about that? There are provider students, they just use context clues. So we have to be very careful when we are designing such kind of activities. So you have to provide some context. And it's really hard to understand things which are out of your context. Okay, so I'm sure that you know it already. So another thing is integration. So allow your students to realize that integration of concepts in science is very important. Okay, so there's a hierarchy in terms of system. There is organization, and despite the fact that we are looking at the world, no, it is the same world that we are looking at but we are using different lenses like physics, chemistry, biology. But at the end of the day, they are actually they should be combined. Okay, one subject or one area of science should also support the other so that you would have an integrated study and at the same time an understanding of the whole system. So it's very important. So if you fail to do this, then most of the students would think that what they got from their science is actually fragmented, and somehow they cannot make sense of some concepts because of that. Okay, so allow your students to think on how they will use the acquired knowledge in solving the concerns of the society. Because most of the time we think that this scientist should look like this. Or can they really see molecules of the, for example, strands of a DNA? Can they do that? Most of the time, people would think that scientists are like this, diba? When students enter the science courses, they are doing this. But actually, we should not stop ourselves from or we should not think of science or being a science major this way. Actually, you should allow your students or somehow encourage them to use the knowledge that they have in terms of one, understanding the natural phenomena around them. Aside from that, solving the problems that are found in their immediate societies, environments. So that's one thing that we have to prepare them for. And another thing that we have to consider is that culture plays a very, very important role in terms of understanding and appreciating science. So for example, and also the context is very important here. For example, you're talking about law of inertia, and then your example is jeepneys, passengers on a jeepney, passengers on a train, that suddenly stops or suddenly started to move from rest. What happened to the passengers? Those are the typical things that you see from the book. And then somehow you realize that some of your students are not actually aware of what a train is because they haven't seen one, but they are aware of this one, yung carriage wherein you have your carabao there or other animals. No, so you can see that scientific laws naman are applicable to different examples or systems. So why not use what is in their immediate environment? So that's it. Generate activities that will stimulate their analytical thinking. So you're familiar with the problem-based learning approach, and so it infuses, of course, the different details of inquiry-based learning, and of course, the usual thing of about scientific method. So since we are familiar with the PBL as opposed to, for example, traditional learning, we can somehow design activities that will encourage our students to undergo this type of inquiry-based learning. But I would like, the caveat would be the time, of course, when you are giving some PBL activities that will really take some time. So you just have to give them one or two in a term. and then just monitor their progress and work with them. So that's it. And then some other things that we can do when we are delivering lectures, you can actually practice this flip classroom. Wherein, when they come to the class, they are not all, well, the heads are not empty. They should have watched something before they attended your class. They should have some questions that somehow lingers in their minds, and then they have to ask the question to you, so that the class or the discussion will be more meaningful. That's what we want. Of course, questions may be that are very difficult or that may be difficult to answer should be given as an assignment or otherwise some task that supports that. And flipped classroom is very important because nowadays, for example, we have the synchronous session. The synchronous session is not very long, right? Sometimes it's just 1 hour, 1.5 hours. And for you to introduce a topic, it's very challenging, especially in science, especially if it is a majorship subject. That's why you have to, some of the teachers create some videos that their students can watch. Now, the limitation there is not all of your students can watch the video. So what you're going to do is you have to, of course, make some adjustments when you are in the class. But it would be an advantage for those who watch the video because they have some questions that they can actually ask you when you discuss. Okay, and then of course the inquiry-based methods, for example, the 5 E's and the 7 E's should be considered when you are creating or designing some lectures in your class.